Hi gang, Stat 1150. As promised, this video is going to show, demonstrate how to use R to conduct a t-test. This is just a life-changing video. I tell you, you'll feel so accomplished, or maybe you won't. I don't know. But I think it's kind of cool and it's super easy. And it beats the heck out of typing the numbers in your calculator, especially if you have a large data set. So. Let me show you how to do that. Let's go to the question, and yeah, this is it. So you can see the random sample of 20 independent female college-aged dancers was obtained, and their heights measured. Assume the population distribution is normal, and we went through this. Okay, so but we worked this problem using the graphing calculator. So I want to show you how to work. Using R, which would be much more realistic if you were actually encountering a problem like this in your profession someday. So what I would do is I'll click the icon to see the numbers, and I can go to this little icon here to click to copy the table. So I'm going to copy in Excel, and it's a small data set, so it won't take long. So I'm going to open up R, and I need to come in and give it a name. So I'm going to do an insert, and I think these were what, heights? So I'm just going to do ttest. Now I'm going to go up and do a save as, and I want to save this on the desktop because that's where I will tell. I'm just going to be creative here and call it data or not. I'm going to save it to the desktop, and then the file format that I want is the .csv, comma, separated values. The guys, don't get goofy down here and do something. Granted it says .csv, but that's Windows, comma, separated, and MS-DOS, comma, separated. These two choices right here will not work. It needs to be the comma separated values .csv. So I've got it saved as generic data. I'm going to save it. It'll come up and make you feel all goofy. Just hit continue, and we have our data saved on our desktop now. Okay. Now what I want to do next is I want to get out of this stuff, and I want to bring up R. So first thing I'll do is set my working directory, and I'll do that like this, and then I want to go get my data. I'm just going to call it data again. Read.csv. That's the reason we put our file into .csv format. And I think I just called that data, didn't I? So I need to attach the data so I can read it, and I can do stuff with it. Now, a lot of people like to see the numbers, and if you do, do it. It works. Now, the very first thing that I had over here, I want to make this smaller, and then I want to bring up this. So let me exit full screen. And all right, cool. So I've got my data out of my math lab onto my desktop, and now it's into R, so I can work with it. So if I wanted to find the mean, all I would need to do is just type mean and do ttest. So the mean is 63.15. Different numbers than before, which is less than or below 64.5. Now the next thing is determine the null and alternative hypothesis. So we want the dancers have a smaller population mean, and for reasons that I discussed in the previous video, we know that this has to be the format for the null and alternative hypothesis. Now the next thing, we need to run the test. So we're going to need the test statistic and the p-value. So what I would do here is I would use the command in R to make that happen. So let's get this out a little bit bigger. All right, cool. So the way I do that is I go t.test for HTS. Now, I need to set my null hypothesis, and I do that by setting mu, and I want that to be equal to 64.5. So whatever value is right here in the null hypothesis, that's what I'll set mu equal to. Now the next thing I have to do is I have to tell R that my alternative hypothesis is less than. And the way I do that is just type alternative equals less. And the next thing I want to do is I want to get my confidence interval, and I want a 95% confidence interval here. And to do that, I would just do level, I believe. And I just do 0.95. All right, so I've run my t-test, and the test statistic here will be negative. I go to two places, so I'm got a negative 2.58. And my p-value is go to three places, so that's going to be that 9 will stay at a 9, so 0.009. And then I come into my interpretation, and I say since the p-value is less than or equal to the significance level, we're going to reject H sub O, and there is sufficient evidence to conclude. All right. So guys, that's all there is to it. So to get your information from R, that's very, very, very easy. Now, what if I wanted to work this problem with R? Well, I could do the same thing. I could, click this, open in Excel, same thing. Or since I only have 12 numbers here, and it's not an extremely large data set, what I could do. What is this called? Pulse. I could just name it something like Pulse and enter the numbers into what I call the C function. I can't just type those numbers in. I have to type them in C and then separate the values with commas. So 21, 10, 11, 10, 16, 7, 0, 4, 12, 43, and 16. Sometimes students will ask me, do I need to include that 0? Absolutely you do. That is a measurement. That's an observation on a particular person. That particular person, there was no difference in their pulse rate before and after running, which is rather interesting. So we want to see if the pulse rate was more. So for reasons I explained in the previous video, I'm looking for the alternative hypothesis was greater than. So I know with complete certainty it's going to be D. And test statistic. All I got to do now is just do the same thing, t.test. But I think about it, I really want the same stuff, the same format as I have there. So what I'm going to do is I'm just going to go up and get it. So I'm going to hit the up arrow to get this. Now I just need to change the HTS to pulse. My mu from 64.5 to 0. And my alternative is not less, but greater. And I want my 95% confidence interval to be confidence level to be 0.95. All right, so I set the values here. So the test statistic in this case would be 4. Well, we're going two places, so 4.12. And the p-value is, what are we going to? 3 places, so that's going to be 0.001. And just as before, a p-value is less than the significance level, so we reject the null, and there is sufficient evidence. Now, got something kind of goofy going on here. Notice that the 95% confidence interval has a format that doesn't give you, it gives you a left bound, but it doesn't give you a right bound. And the reason is because this alternative greater than is messing up this calculation. So if I want the 95% confidence interval, what I would need to do is rerun the t-test, but I need to get rid of this alternative greater than here. Okay? Now what this is going to do, by default, it's going to run a two-tailed test, which in the context of this problem I don't want. But it's going to give me the correct 95% confidence interval of 5.82 up to 19.18. You know, I think it's a little goofy that R does that the calculation of the hypothesis, or I'm sorry, the confidence interval that way when you conduct a test of hypothesis. But you know, that's the way it goes. Okay, guys. Speaking of, I want to go back and look at question 1. No, I don't. I want to look at question 2. All right, so question 2, find the 99% confidence level for the population mean. He should use what for the t-star? How would we do that on R? Well, what you do on R is you use what's called QT. QT is the same thing as inverse T on the TI 83 or 84 calculator. Now the first thing I put in is I put in the left bound just like I did before. And again, if I think about it from the drawing that I did in the previous video, if I got 99% confidence level, I need to find the two values that kind of capture that middle 95%. So I have 1% missing. Half of 1% is a half a percent as a decimal 0.005 for the same reasons I talked about earlier. Now I have 24 measurements, so I need my degrees of freedom, which are 23. And guys, I get my t value. So in 3 places, now remember this always goes in as a positive, so I have the 2.807 as the answer. Alright gang, that's all I got for you, just to shows you how you can use R to do the same stuff we do with the graphing calculator. Alright, have a good one.